discontinuities and asymptotes. So how can we identify removable and non-removable discontinuities and then find the asymptotes of a function? So discontinuities to start off with. So basic definition, a function is continuous if you can sketch it without picking up your pencil. So if we look at this function, I can draw it all in one go. I don't have to draw it, pick up, draw it again. Same with the other three. So if a function is not continuous, then it has to be discontinuous somewhere. So we're going to talk about 3 types of discontinuities. There is 4, but that 4th one you'll get to in calculus. So 3 types of discontinuities, and they're going to be on this next slide. So jump is when you have a jump in your graph. So here, like you have this, and then you jump up to an open circle. A infinite discontinuity are your asymptotes. And a note here, these 2 are sometimes called your non-removable discontinuities. So the last one is your removable discontinuity. This you can also think of as a whole. The reason they say you can remove it or it's removable is it's just discontinuous right there at that circle, that open circle. So I could define a value and I could plug that hole and make it continuous. I can't do that with the other ones. If I tried to do that here, well, then it's not going to be a function. I'm going to connect everything, and then that's no longer passes the vertical line test. Same thing here. If I try and connect those, it's no longer passing the vertical line test. Okay, so for these 2 functions, you can either graph them on your calculator or you can graph them by hand and figure out, is there a discontinuity at x equals -1? If there is a discontinuity, is it removable or non-removable? So take a second to do that. All right, so a sketch of these graphs. This first one is going to look something like this, and the second one is going to look something like this. So your calculator may not have the open circle so obvious, but if you look at your table and trace it, there's going to be an open circle right there. So this one would be a removable discontinuity. This one would be a non-removable. So on to vertical asymptotes. So here's an example. You have this function x squared over x minus 1 has a vertical asymptote right here at x equaling 1. These asymptotes usually come from what makes the bottom 0. So if you have x minus 1, you can't have x equaling 1 because then you're dividing by 0, which is not allowed. So why does this happen? So you don't need to remember this, but basic idea. If we say x equals 1.1 and we plug it in to this function, we're going to get something about 10. If you then plug in x equals 1.01, so you're getting even closer to 1, you're going to get a value about 100. If you plug in 1.001, so we're just getting closer and closer and closer to 1 as we go, you're going to get a value about 1,000, and then this continues on. So as we get closer to 1, we're going way up in our values. So we have a vertical asymptote. The note here, rational functions usually have a vertical asymptote whenever the denominator is 0. So these are the 2 from the beginning. One of these has a vertical asymptote and one of them doesn't. So think about which one. Okay, so if we simplify this, we can factor out an x squared. And then these would cancel, so you end up being left with x squared. Here nothing cancels, so this one is going to be your asymptote 1. This one has a hole because you canceled these 2 values right here. So whenever the bottom equals 0 and you don't cancel something out, that's going to be your asymptote. If you do cancel something from the top and the bottom, that's going to give you a hole. So then next is horizontal asymptotes. So what are they? A horizontal asymptote is a way of describing what happens at the ends of your function, so you go out to each side when x gets big or really small. So as an example, if I sketch this in like this, you would have a horizontal asymptote here. You're looking at what's happening at both ends. You don't really care about anything in here, it's just the ends that are important. There's 3 cases. Don't worry too much about writing these down because I'll put them up on the next slides. But you can either have a higher power in the bottom, you can have a higher power or equal power on top and bottom, or a higher power on the top. So the first case is the highest power in the denominator. For this one, you're going to end up with a picture somewhat like this, or similar to this. And your horizontal asymptote is going to be right here at y equals 0. So here you have a horizontal asymptote at y equals 0. A note here, you need to have that y equals. If you don't, you're just talking about some random 0. There's no way to know. Are you talking about a horizontal asymptote, a vertical asymptote, like what's going on? So you need a y equals 0. If you're doing the vertical asymptotes, you need an x equals when you write it out. Second case, here your powers are the same. This one will look something like this as an example. And your horizontal asymptote is right there. That value is actually going to be y equals 2/5. It comes from your coefficients. So you have a horizontal asymptote at y equals a over b, where a is your top coefficient and b is the bottom coefficient. So this would be your a and this is your b. All right, third case. You have a higher power on top, so up here. This is going to look like, or something like this for this example. What happens here is this higher power kind of cancels out your horizontal asymptote and you just don't have one. So there's no horizontal asymptotes at all. So some examples. So without graphing this, we want to figure out what are the different types of asymptotes. Your first step is to try and see if there's anything you can factor, which we could factor out of 2, but it won't cancel anything in the bottom, so we don't really need to. So we're looking for the horizontal asymptotes. We need to figure out our 2 rules. So you can look here, we have the same power. So our coefficients are 2 and 1. So you get a horizontal asymptote at y equals 2. If you're doing the vertical asymptotes, we just care about the bottom value. So we're going to get x equals -4 because that would make the bottom 0. Same question here. And note, you want to do your horizontal asymptotes before you simplify because you want to look at your exponents together. So we're looking at these right here with x squared and x. So our higher value on the top or higher power on the top, which then means that there are no horizontal asymptotes. If you use your 3 rules, you should memorize those for the quiz and test, by the way. So then if we're going to do the vertical asymptotes, we need to simplify this first because there's no way right now to know what's going to cancel because we have a quadratic on the top. So if you simplify this, this will factor to x minus 4, x minus 1, all over x plus 2. So nothing cancels, so we do have a vertical asymptote. If, for example, we canceled out the x plus 2, that would give us a whole. We have a vertical asymptote at x equals -2 because that's what makes that 0. And that's it. Your homework is worksheet 1.2.2. It should be on Schoology.